Are you planning for training a deep learning model over a large amount of data, and you're wondering to know how you can distribute training your deep learning model over multiple GPU and even multiple nodes of a cluster of GPUs in Azure Machine Learning? If yes, then welcome to this video and let's go! Hello everyone, this is MG and I highly hope you're feeling great. In this video, I'm going to talk about how we can do an end-to-end distributed deep learning for training our models over multiple GPUs in Azure Machine Learning. And specifically check it out how we can do so using AzureML SDK v2. So let's check that out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Alright, let's check it out how we are going to achieve a distributed Pytorch based solution on Azure ML. And for this specific example, what we're going to do is having a distributed Pytorch image classification. So what is the object here? First of all, we're gonna check how we can have a parameterized solution for distributed Pytorch training. So later on, if you want to do for your own sort of use case with your own data set, you can just use the example that I'm providing a walkthrough, and I will add the link of this notebook also in the video description. You can check that out. So how we can quickly scale this template or solution without too much of code changes, and how we can quickly run a distributed Pytorch training over multiple nodes of a GPU based cluster using Pytorch. We will also use, as you will see, mlflow for tracking and analyzing any metrics and logs that we're gonna load later onto our mlflow server, which is also supported by Azure ML. We will tackle that as well. And in order to achieve this sort of implementation, first you have to make sure that you have an Azure ML workspace within the region that supports GPU. So make sure you can also create GPU here. And we were gonna use also Python SDK v2 of Azure Machine Learning. So when you come to Azure ML, you have your compute running here. Make sure that your sort of kernel choice is based on SDK v2, making sure the code gonna work successfully. So let's dig in a little bit further. What's gonna be the first thing that we always do in a notebook, right? Connecting to Azure ML. And we know that as always, when we talk about SDK v2, we start with checking out if we can get the connectivity through default Azure credentials. If not, this code gonna open up an interactive browser that we launch, do an interactive authentication, and we're good to go to come back to this cell. For me, it didn't ask, so I ran this and it was good to go with the default one. Now, in order to connect to workspace, to Azure ML workspace, to start coding and using Azure ML capabilities with code or SDK, I have to connect to Azure ML client. You need to just add your subscription ID. I added and I ran the code, but I removed for recording the video. Then your resource group name, your workspace name, and the credentials that you grabbed from the top. And now you're authenticated to Azure ML, and whatever you want to do with Azure ML workspace, you just have to refer to this ML client object. Now, what is the first thing that we need to do? We need to configure resources. You can configure CPUs or GPU machines. The code and logic of how to create a cluster of computes with Azure ML SDK v2 is exactly the same. For giving you an example here, I ran this code. This is creating a CPU cluster for me, so that's the name. And what this code will try is first checking out if I have a cluster with this name already in my Azure ML workspace. So try this. If it's already there, it will print and say me that, hey, you already have a cluster named blah 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 CPU cluster. If I don't have it, it will start to create that compute for me. So it's gonna ask me, okay, you want to create an AML compute that is coming from SDK v2. Give me a name. What is the type? That's an AML compute. What is the virtual machine type? That's CPU, GPU. Give me the name. So this one has certain amount of memory, of number of cores memory. We can check them out in the compute section if you want to know what is DS3 v2. And the minimum number of nodes and maximum number of nodes you're gonna have for the cluster, the time based on seconds, which is the ideal time. After 180 seconds of inactivity, the cluster gonna get shut down. So that's a good practice to have it in place for saving cost, and that's gonna be a dedicated compute, making sure it's always available when we call it. And that's it. It will start to create this compute based on the configuration that I have specified here. And I ran this. I think I had it already, so it didn't create for me. Yes, I had the compute. So for GPU, which is the one we need for this distributed Pytorch training, the same thing. I'm using a very similar code that comes with this template, but of course the configuration is different. This is gonna be a different name, and also the type is different. This is a NVIDIA Tesla K80 GPU. I am creating a cluster of 4 nodes, maximum 4 nodes. That doesn't mean when I say 4 nodes, I'm gonna pay for 4 GPUs. No, that's max. That means when it is needed, and when you specify using all of them for distributed training, then you're gonna get charged for that. It is there for you, reserved for you to get launched, but you don't pay for it unless you execute code over them. That's it. I created my compute, and let me show you actually quickly before I move forward. So here in my compute section, let's wait a bit to get loaded. There you go. I have my compute clusters section. There's a GPU cluster created for me. You can see there's 0 nodes running, so there's no workload. I'm paying for nothing, but it can go all the way to maximum if it's needed. And then that's the GPU type that I talked about it. So each node of the cluster has just 1 GPU. So 1 GPU instance per node. So I can have maximum 4 GPUs over 4 nodes of a cluster if I need it for distribution. Okay, now I have my compute there and I have connected to AzureML. Then what is the data I'm gonna use? So this template is using 2 datasets or 2 examples. One of them is a Stanford Docs dataset, and the other one, which is more and larger, is Places 2 dataset. So we're gonna use the first one because the second one is more heavy and it's gonna take time for distribution. I'm gonna execute the code, and I did it actually for a smaller dataset, which is this one. But if you're gonna go for larger dataset or your own dataset, the codes and logic, it's very similar. So I ran this one, was very fast. I think after 10 minutes I was able to finish training. But let me show you what is this data very quickly. So that dataset, which is a public dataset, contains 220 bits of different docs, almost 2,580 different images. And just show you quickly, you can see different categories listed here with sort of the number of the samples underneath. So just different doc examples here. So in order to sort of having it accessible by AzureML or this compute or this GPU machine that's gonna train the model, well, I need to download it, right? The data set that I just mentioned, this Stanford Doc data set, will give you the data in tar archive format. So you have to unzip or uncompress the data. When in your local machine, you know how to do it. You can just run this command line and you can download the data, unzip it or make it out of tar format, then exploit it to training and testing, and we're good to go. But we can do the same thing directly in AzureML. So why you do it locally on your machine and then upload unzip data to the cloud or Azure? Let's run this command line as a component or a job in AzureML. So if you don't know what is AzureML component that comes with SDK v2, there's a separate video I created. I'm gonna add that to the top right of the screen. But here, command is like a component in AzureML is like a function that has input, some codes, output, and a compute to run, and an environment to run. When I say environment, I mean the packages needed to be installed to get it run. So here I'm defining a component here through a command line and saying that, hey, I want to create a command. What is the command? What is the component type? What you gonna run? Are you running a Python code? Are you running a YAML file? Whatever it is. I'm saying that no. In this, I'm running just a command line, and this is my only code, right? But this is a component, so it needs to have, okay, the code, I have it here, which gonna get the inputs, which is the URL of my dataset, and the output is the unzipped or uncompressed input as an output images that I'm gonna train my model. Okay, now I have the code there. What do we need for component? I said code, input, output, and 2 other things that I'm gonna talk. So we talked about code. What are the inputs now? I have to specify the input. What is the input type? That's a file, a folder, what it is. It's a URL. This is the place I have the dog images that I mentioned. Okay, what is the output? Well, the output is a URL folder, because that's a place in Azure ML on cloud that I want to upload this unzipped data there. Perfect. So I define the code for this component, the input type and component, and also the output. What else I need for Azure ML component? Two things left. Environment, which is the packages or container image needed to run your code. Here I'm using a curated environment, comes with Azure ML. So that's a container image created by Azure ML. Everyone have it in their workspace. That's a container image that contains some basic scikit-learn packages, which is good enough for running this code, right? And a compute to run this code. Remember we created a CPU cluster? That was the reason. I want to use a CPU machine to unzip this file because it doesn't really need GPU to get this data ready, right? I'm not doing any training. So I ran the code and I figured out all done successfully, as you can see here. So now I have the data accessible for me in this path, right? Now I have this sort of component already defined for me here, but I haven't executed yet, right? So in order to execute this component or command, we have to specify a command job through the workspace that we got already authenticated, which is the client that I have it. So go to this AzureML workspace, create a new job for me. And what is the job? This one. I define it on the top with all the details. So it will go to that workspace, we authenticate it, run this, and the code also gave me the URL so I can check out my job running successfully or not, right? All the time that you want to go with the larger data set, the other one that I told you, but we're going to skip this. So very similar thing, I'm creating the same component, but this time the inputs and outputs are a little bit different because that's a separate data set. So I'm going to skip that part and go all the way to training a distributed GPU job here. So distributed training can be a little bit complex, but what this sort of template is doing, it has created already modularized Python codes. For example, you see the train Python that we're gonna call this Python code through a component that we're gonna define here from based on Azure ML SDK. And because it is parameterized, you can use it for different use cases, right? So here I'm saying that, hey, I'm gonna create another component very similar to what we did for unzipping the data, right? So again, you call component, and remember you need code, input, output. So what is my code? Well, this time my code is a Python. So my command line is Python. You know how to run a Python code, right? You open your command line, you type Python, and then the Python code that you have. And of course, this Python code has parameters that you have to specify. Give me the training data set, the validation data set. What is your batch size? What is your number of worker nodes? Learning rate, all sort of different factors you need for training is parameterized. You specify them here. And again, now this is the code, right? Okay, what is the input? My input is training data. Where it is? Well, we uploaded here previously, right? Okay, that's the same place. What is mode? You are telling to Azure ML that when you train your model using GPU cluster, download all these data sets from cloud to the GPU cluster memory. Download is the only way to do so? No. Downloading is faster because you get all the data to your GPU cluster, so it is accessible for GPU, so it will train faster. But the other mode is mount. When your GPU cluster memory is not enough to download all your data, you can mount your GPU cluster to the storage that you have your data on cloud. So through mounting, it will gradually reload the data to memory and do the execution. So I would say, long story short, when your data set is larger than the memory of your compute, go with mounting. Now the same thing for validation, same path, but again the mode is download, and that's the time you have to put the inputs for these parameters, right? This is the place I'm putting the value for the variables, the batch size, number of nodes, number of the epochs, linear rate, so on and so forth. So I'm gonna move further. That's a typical training parameters that you all know. And of course, for running a component, we need code, input, and what else? Environment. Here's the place that I have specified that I'm gonna run this training over a container image that Azure ML specify. What is the name? It's called Azure ML Pytorch. This comes with Azure ML. Why it is taking, why I'm using this? Because it is already got efficient for Pytorch training on GPU. So why should I create a container image, define my pip packages stuff if it's already there and defined for my Azure ML? So I just call it with the name. If you're wondering how this name is coming from, if you go to environment section of Azure ML, you will see a list of environments. This is picking up the one that comes with Pytorch and GPU, which is relevant to the use case and what we're doing. Now here's the interesting part. There's a new component we see, object we see in Azure ML component called distribution. So here is sort of a magical point that you just specify what is the type of distribution you want to do, and of course how many process you want to have per instance, per node that you have. So each node of my cluster has just one GPU. That's why for per each node I have just one processing. That can be 2, 3 based on the number of the GPUs you have over one node. And how many nodes that I have, I can go to max 4, but here this example gonna use just 2 of them for distribution, right? So just as simple as that, I'm specifying my distribution configurations, and without dealing with creating and configuring everything from scratch, and it will automatically do the distribution for me. But if you want to know what other type of distribution, for example, you can specify here, let me open up the documentation for you. So I am in Azure SDK v2 command that we are using, and one of the parameters that we have to, or object that we have to specify distribution, and you can see the distribution can be Pytorch, the one that we're using, can be TensorFlow, or MPI, which is the main base backend of how the nodes talk to each other. That's like defining the protocol of how nodes over distribution can talk, right? And if you click on any of them, let's say MPI, PyTorch, TensorFlow, you can then see, if I go, let's say with PyTorch, what I have to specify, the process count per instance. Remember, the default value is 1. That's what we specify in our notebook. If I go with TensorFlow, more stuff that I need to specify. So going back to my notebook, I specify distribution. Now I have defined this job, but I haven't executed yet. The same thing. I'm gonna go to say that, hey, over this AzureML, create a job. This is my training job, and I give it a name to this experiment. And I was able to execute this. It gave me a URL, so I can later on click on it, check that out, how the training performance is going on. There you go. I came to this job and I saw that, well, my training got successfully created. So it took almost 90 minutes. And by the way, the training.py that we have specified, I'm going to show you quickly. It is using mlflow inside this code. So many logs and metrics by mlflow got tracked for me. The parameters that I specified are tracks. Check that out. The metrics are logged for me. And of course, mlflow server has been used as the main tracking system. I can check out further metrics. If I click on metrics, you can see all of them has been visualized, so I can check out the performance of my training as a job. Further, I can analyze the logs, metrics based on mlflow logs that it has tracked, right? So you know that Azure ML has an mlflow client. You can set your mlflow server as Azure ML and then go and grab the metrics that got created out of that training. And you can see I printed my mlflow runs. You had the one run, that's why there's just one run specified. I ran this code just once, which got finished successfully. And check out some metrics got registered that we just saw as a chart also in the UI I just showed you. And even further, all the logs that I mentioned, you can grab it and also play it by yourself too. So I use, for example, the mlflow client of Azure ML. From the run ID that I had, I get the metrics history and I plot it. Similar to what I just showed you here, right? Exactly. So you can sort of see the default one created here, or grab the logs in your own metric and do any sort of your own analysis on the metrics that comes with mlflow. So that's it. That was the template that I used and I executed to provide you walkthrough of a quick distribution training with Pytorch. That can be as simple as define your own component and specifying your distribution type with the parameters needed, and you're good to go. But on backend, of course, it's much more complex. It is calling a train.py that we haven't talked about. What is that train.py? I quickly gonna show you. This is the template that comes with it. You can see that the setup configuration based on some parameters you specify. For example, it is using some what if functions. If you specify a distribution backend as NCCL, which is mainly for GPU, okay, it's gonna set up some specific configuration. If it's MPI, that's another sort of a specific configuration. So this notebook is doing is best to make it generic based on the input you provide. It gonna set up the distribution configuration for you, and the rest is just a typical way of training model with Pytorch, as you might be familiar with, right? And specifying mlflow, training the model, grabbing the data based on the input, and logging some specific metrics using mlflow. And it is modularized, so this train.py might call some other Python codes from other modules here. So I'm gonna add again the link of this example of end-to-end distribution that we just provided a walkthrough. That was fairly quick, and I know on backend each single component of distribution we talked about MPI, NCCL, Pytorch, TensorFlow. That can have its own dedicated topic and video to provide a deep dive of how distribution on backend works. But at least this sort of tutorial that I aimed for was something that you can start from, check out the capabilities and dig in further. And if you want to know further more for any component that I just touched today, please write down in the comment. I would be more than happy to check out what else you want to hear more, so I can have a more specific topic on any component of distributed training in AzureML. Hope you enjoyed the video so far, and that's all. Keep your eyes on the stars, but your foot on the ground. Dream big, my friends. Take care, and we will definitely meet each other shortly in the next video. Bye for now.